Hello guys and welcome back to how to create a climbing system like in Assassin's Creed. This is the second part of this tutorial series, and today we're going to create that you can actually move towards a point when you have found a spot. So we're not going to create that you can actually find those spots, but only that you can move towards it. Also, my voice may sound a little bit weird. That's because last week I was a whole week sailing and still a little bit tired, but because in 4 hours I need to upload this, I had to record it right now. This is also the third time I record this, because every time something went wrong. So, well, I hope you guys like that I put so much effort in this series. So what we're going to do today is first create like a scene where we can just walk around, and just a scene where I can just explain what's happening within the script. So the very first thing we're going to do is going towards the standard assets, and then going towards the prototyping to the prefabs. And here's like a floor prototype, which is really big. We're just going to reset it. So it's just on, well, the center of this whole scene. After that, we're going to create or we're going to put in a scene from third person characters a prefab called third person controller. And well, now we can walk around, but you also need a camera. So we go towards the cameras, we're going towards the prefabs, and we're going to put the free look camera rig inside it. So we're just going to change this to 555, and then we've got a very laggy camera like in Grand Theft Auto and so on, and also in Assassin's Creed. This is very laggy because it's not optimized. It shouldn't be like this. Let me just put it right that, but it works and it's fine for this tutorial because we're not talking about cameras but only about a walking system. So now we can just walk around. So that's everything here. The last thing we're going to add is a cube. And this cube is going to be just so I can explain some things. And here is going to be, we're also going to make, before I forget about it, an empty, and we're going to call it a hand. And we are going to put it right on this position. And this hand is going to be, well, very important because the pivot of this character is right here. And if you're hanging, you're not hanging on your feet, you're hanging on your hands. And your hands are around this position. We probably need to tweak it a little bit during this tutorial series, but that's somewhere on this point. So we need to make sure that, well, that is on the right position. So when you're now hanging with this system, you will hang, this will be at the edge, this position, and you will just hang on your hands like in a thumbnail instead of hanging on your feet or something like that. So now we're going to create a new script, and we're going to call it wall climber. You can also call it different, but that's how I'm going to call it. Very first, we are going to, let me just zoom in a little bit. I hope you guys can read it. We are going to use the Unity standard assets, and we're going to use from that the characters, and from that third person. So we're going to create a new function, and the function is going to be called move towards point. A lot of this function is going to be logic right from what I'm going to explain, because you need to move towards point, but some of it is going to be a little bit hard to understand, and that's because we didn't create a whole system, and we're going to do function. Each part of the series we're going to do a different function, and I don't want to forget anything about the function, so that's why we're going to do one function each time. But it also means that some parts are a bit are not totally logic that we are already creating those, but I hope you guys will understand it. So the very first thing we're going to do is we're going to lerp the position of the transform. And of course, the very first thing you're going to do is you're just going to use your own position. Between those brackets is going to be the calculation where the next point is going to be. and here is going to be the time. So just time dot delta time. But you also want to change it. In some games you want to be very fast. You can climb very fast, and other one is just going to be very slow, and so on. So you are going to create a public float called climb force. Also about this, how we're going to assign as variables. On the very first few lines are going to be the public floats where that you are going to change, different on each game. After that are going to be the variables you are going to assign before the game starts. Just like, for example, the animator and the third person user controller. That are just things that always need to be assigned, and you don't change that ever after you assigned it, but climb force, you are going to change it probably. And after that we're going to do the private variables that are only important for the script itself, but not important for after if you're going to tweak it. And we're going to already create two of those private variables. So a private vector tree called target point, and this is the point which you find after you did all kinds of checks about where the next climbing point will be. So for example, you are standing here and it will just check, oh, here's an edge, oh, we can this is going to be the next point where we are going to be at. So that's the target point, but we are also going to create a private vector tree called the target normal. And for all the guys who don't know what a normal is, a normal is the side a face is facing. So for example, you got this cube, and this face is facing in a z-axis, and this one in the x-axis, or I mean this face, and this face is facing in the y-axis, and so on. That's because you also want to change your rotation. So how we are going to do that is going to be explained within a few seconds. Otherwise it's going to be a little bit too much at the same time. So we're going to multiply this by climb force. For some reason I have to type it by myself, but it's not a big deal. And we're also going to have a public transform called hen trans. So that's the hen transform on which I spoke earlier this tutorial about the offset you will have, because here you just have this little bit of offset, whatever you want to call it. So a target point minus transform.rotation. So this is maybe a little bit weird, but I'm going to explain it within a second. And hen trans.local position. So the new point where you want to be is actually just target point. So, and the target point is the edge where the hand transform is going to be hang on. So this position, so this empty needs to be in the end at the edge where you are hanging at. So it's a bit logic that the target point minus that local position is going to be that place. But why the transform node rotation? And that's because if you're going to rotate the third person controller, the actual Z axis, so transform dot forward, is different from when you're going to rotate 19 degrees, because then it's forward, it is the X axis. But on the local position, that is not going to change. So you just need to assign also the rotation. And it's very important that you put the rotation before the vector 3, because if you're not going to do it, you will get a lot of errors. So this, just to make an example, if you're going to put this behind a vector 3, so here, you will get a lot of errors, because I don't know why, but if you put it just like this, everything is fine. So that's just a little bit important before I get a lot of people who will have that error. So the second thing we're going to do is actually make sure that you are going to face towards that place. So you got the look rotation, and that is the look rotation, and then minus the target normal. Why minus, may I ask? So if you got like a direction that is going to, from this cube, if you are at this point, you will to hang on this edge. The normal is minus the Z axis, but if you're going to have that same rotation, your face is going to hang, so you will look like, if you're going to have the same rotation, it is going to be like this, right? But actually the thing you want to do is that it is like this. So what you need to do is have the opposite of this direction, because then you turn everything 180 degrees around. So that's kind of how it works. So that's the look rotation, and now we're just going to slurp the transform.rotation towards it. So just slurp it. Transform.rotation, look rotation, time.delta time, and again multiplied by the climb force. Now we're going to do a little bit of animation. So we are going to assign, or we're going to create a new variable called animator. And we are not going to make any animations in this tutorial series because I'm not very good at making animation, and we'll just give you some crappy tutorials. So I'm not going to do that, but we're going to use the jumping animation when you are on the highest point. And as you can see, let me just window animator. Let me just put it right here so we can see what's happening. When you are at let me just go to parameters. When this is at -9, and let me just, it's not on ground. Oh, it's probably I didn't select this one. Well, for some reason, it will just look like this. And this is fine enough for us. So to calculate, we just want a little bit of animation so that it is just like you're just setting yourself off the cliff and you're just slowly jumping towards it. So we're going to use percentage of things. So the very first thing we need to create is a private variable, private float called the begin distance. And this is the distance when you just first start. When you find a spot, you can just calculate what's the distance, and if you calculate here what's the current distance, if you're going to divide it by each other, you will get the current percentage, and you can calculate on which date the animation needs to be. I hope that makes sense. So the very first thing we're going to do is set a bool, because it isn't on ground anymore. So if it isn't on ground, only then will this whole animation work for some reason. That's just how the animator is set up within the third person controller. So a float distance is going to be a vector3 dot distance, and it's a transform dot position. And we are again going to do actually the darkened point minus the transform dot rotation multiplied by the hand trans dot local position. So now we got it. And now we're going to calculate the percent to that. The percentage is going to be not the actual percentage. We're already going to do one step ahead, because I know the maximum is -9 on the animation we use. So in the end, we want to do this, we want to set this on -9. So what we're going to do is -1 multiplied by the distance divided by the begin distance. But this is going to be a problem, because this one, for example, at start your distance is going to be 10, and well, on the end it is going to be 0. The problem is that if your distance is going to be closer, this is going to be less, and we don't want to let it be less. We just want to make it that's going to be slowly up. So what we're going to do here is going to do oh, whoops. We are going to do here begin distance minus distance. So now we just got, well, the right distance. And we're just going to put that inside our animator. And the variable is called jump. And we're just going to put this here. And now we're just going to use, now we're going to check if you are already on that point, because if you're on that point, you can go to the next point and to the next point and to the next point. That's not the only thing that can happen, because there are different climbing swords. This sounds a little bit, probably right now, a little bit so fun. Whoa, that's very complex. This isn't very complex. A public enum climbing sword, because what this does is it will check what you are actually currently doing. So you can walking, so that means you are not using anything of this script. Well, there's one void that's going to check if you're going to actually start with climbing, but we're not going to move towards points or check for spots or whatever. Then you go jumping and falling. Those two things are actually just the opposite of each other. Jumping is when your velocity of the ix is more than 0, and falling is if it is less than 0, so if you're moving upwards or downwards. Then you got the climbing, and climbing just means that you're just hanging on an edge, and that means that you can climb towards a new point, climb towards a plateau, and so on. Climbing towards a point, that means you are currently going towards a point with this function. Then you also got the climbing towards plateau. I didn't spell it right. And that means that if you are currently hanging at this spot, it will just check, hey, is there a plateau here? Yes, there is. So you will just go towards that plateau. And also a checking, and it's last one checking for climb start, and that's when you are at a plateau, and it will just check, is there any edge around here. It's a little bit hard to explain, but it works. But it will just check, well, is there here an edge? If there is, it will move towards a point. But there are two different move towards points. So you got just a move towards point and a move towards plateau. So first we're going to do if you're moving towards another point, a new spot where you can hang at. Then it's going to be the distance is going to be less than, if the distance is going to be this, so that's a little bit, that's not very much. Then it will just say, well, we are done. We are actually just already at this spot, because otherwise this process will take around 1 minute more normally, because it's using a slab from the current rotation or current position towards the new position. So if you're going to move towards, at the moment you're going to move towards a point, it's going to become slower and slower and slower and slower, and at the end it's going to be so slow that it will take forever before it is there. So if going to change the distance to this, if it's smaller than this, it's not going to be visible for the player that is already at that, it isn't actually already at that point, and we just can say it is already at that point, so we can just reset everything. That also means your current sword, you're going to create a new variable called public climbing sword current sword. That also means that that only happens when your current sword is equal to climbing sword dot climbing towards a point. Because if you're climbing towards a plateau, it's going to be a little bit different. So we are going to reset the transform position, or not reset, we are going to make it sure that it is at the right position, where it should be. And that's start point minus transform.rotation multiplied by the hand trends dot local position. So I already explained why we are going to do this, but this is the right position. So now we're going to do also going to reset the rotation, or reset, or actually put it towards the right rotation where you want to finish, and that's this. And now we're going to do something with which I'm going to explain with, but we are not going to use it actually, but it is very important. So a private float last time, and this is because if you're hanging at spot, you just jumped from the ground towards this point. No man that has ever lived can directly within a few frames go towards the next point. You are just not, nobody is has so much strength in his arms. So you have to wait for, well, around 0.1 seconds before you can go towards the next spot. Or maybe if you're using like, I don't know, your game is about a child, it's probably a little bit less, and if your is about superhero, it's maybe a little bit more. Also, it's very important that this is going to make sure that the whole system can reset itself. So if there are any errors, it's going to fix itself and make sure that everything is back to normal. This may sound a little bit weird currently, but sometimes, you know, 1 in 1,000 times, it just thinks, oh, here's also a spot. Well, there isn't actually a spot. Due to this time limit thing, it can actually just see like, oh, there isn't actually a spot. So it just makes sure that there aren't so many things at the same time. It is going to do too many things at the same time, which causes like it's laggy and things like that. So there's just a lot of different reasons why you should do that, and that's why we're going to do it. So, and we're going to set this towards climbing, because after you are if you are at that point, you're just hanging again and you can go to the next position. Then we are going to do almost the same thing if you are climbing towards a plateau. I did put it in another if statement, and that's because some people are going to change here a lot, because you want here a different animation, you want here a different whatever. Because I'm not going to do animation, I'm not going to show you guys how to do that, but it's important. This part is the same on both sides, but here this is going to be walking, of course, because you are standing at a plateau. And here is going to be two things we're going to change. We got a public rigid body called rigid, and a public third person user control, which we're going to call TPUC. And while you are climbing, you don't want that your rigid body is using gravity, which causes that you are falling down while you're actually just hanging on an edge. So what you're going to do is just turn it all off while you're climbing. But we are not here at the start of our climbing, but we are at the end, because you're already walking again. So here we're just going to put it that the rigid is kinematic is false. And also you don't want that you're currently hanging and you can just walk around. That would be a little bit weird. So we also want to make sure that you can't actually use the third person user controller. So enabled is true, because you can, when you are at a plateau, you can walk again. So this is the whole function for today. I know it's a little bit long video. I apologize for that, but it's just a very complex system. And if you want to explain everything correctly so you guys understand the whole system, I just need a little bit more time for it. So I hope you guys like it. If you did, please leave a like or a subscribe. And I see you guys next time when we are going to the next function. And I don't know what we are exactly going to do there, but you'll see it in the next tutorial. Let me just quickly assign everything. That's, by the way, very simple, but otherwise I will probably forget about it in the next tutorial series, and just change this to 1. So this is it for today. I already said thanks and everything, but I also want to thank you for the awesome support on the first video. It's really awesome that all you guys are so awesome about it and just love it. That really means a lot to me. So, stay tuned and till next time.